Hello everyone, welcome back. In this presentation, we'll be studying the significance of Km and Vmax, what is turnover number, and what is the significance of turnover number, and what is the significance of the ratio of turnover number and Km. Now, what is Km? Km is nothing but your Michael-Menton's constant. Now, this Km is specific for an enzyme substrate pair. For a specific enzyme substrate pair, the Km will be specific. Now, what is Km? Km is nothing but it is the substrate concentration when the reaction velocity is Vmax by 2. Okay, what is Km? Km is the substrate concentration when your reaction velocity is Vmax by 2. Now, Km can be expressed in the ratio of all the rate constant. Now, Km is equal to minus K1 plus K2 divided by K1. So, it can be expressed in the terms of 3 rate constant. Now, minus K1 is the rate constant for the reaction when your enzyme substrate complex is being converted back to enzyme and substrate. K2 is the rate constant for the reaction when your enzyme and substrate is being converted to enzyme and product. And K1 is the rate constant for the reaction when your enzyme and substrate is being converted to enzyme substrate complex. So your Km can be also be expressed in the terms of 3 rate constant. Now, Km value depends upon the temperature, nature of substrate, pH, ionic strength, and other reaction condition. We know that Km is specific for enzyme substrate pair. Okay, so for a specific enzyme substrate pair, under specific conditions, that is your reaction, other reaction conditions are same. Okay, specific reaction condition, the Km value will be same. Okay, now if there is any change in Km value for same enzyme substrate pair, under specific condition, that means there is a presence of an activator or inhibitor. Okay, so if there is any activator or inhibitor, then only the Km value will change for same enzyme substrate pair. Okay, under specific conditions. Okay, if there is no presence of an activator or inhibitor, the Km value for same enzyme and substrate under specific condition will remain same. So by Km value, we can see also detect the presence of activator or inhibitor for specific reactions. Now, sometimes your Km is equal to the Ks, that is Ks is nothing but a dissociation constant of your enzyme substrate complex. Okay, so when will your Km will be equal to dissociation constant of enzyme substrate complex? When your rate constant K2 is very less compared to the minus K1. Okay. So when your rate constant K2 is very less compared to the minus K1 rate constant, at that time your Km is equal to the dissociation constant of your enzyme substrate complex. Now, significance of Vmax. Vmax represents the maximum rate attained. It is a rate at which total enzyme concentration is present in the form of enzyme substrate complex. That it is a rate at which all your enzyme concentration is present in the form of enzyme substrate complex. Mathematically, Vmax is equal to K2 into ET. Now, what is K2? Kt is rate constant. Et is nothing but your total enzyme concentration. So, what is Vmax? It is a maximum rate. Okay, rate of reaction versus substrate concentration, this graph, no? So, you can see Vmax is nothing but a maximum rate attained by that reaction. At Vmax, all your enzyme is present in the form of enzyme substrate complex. And mathematically, Vmax is equal to K2 into ET. ET is nothing but your total enzyme concentration. K2 is nothing but your rate constant. Okay. Now let's understand what is turnover number or Kcat. Turnover number of an enzyme is the number of molecule of substrate being converted to product per unit time when your enzyme is fully saturated with your substrate. Now Kcat it represents your turnover number and its unit is per second. And now let's understand by mathematical equation. At saturating substrate concentration, Vmax is equal to K2 into ET. Et is nothing but your total enzyme concentration. Or you can say K2 is equal to Vmax divided by Et. Now this which is equal to Kcat. So Kcat is equal to Vmax divided by Et. Et is nothing but your total enzyme concentration. Now this equation represents your turnover number. Okay, now what is turnover number? Turnover number is number of molecules of substrate being converted to product per unit time when your enzyme is fully saturated with your substrate. Now let's understand the specificity constant. At low substrate concentration, most of the enzyme is free. So your enzyme concentration is equal to E0. E0 is nothing but the total enzyme concentration. Now when you at that time your Michael-Menten's equation will become, that is V is equal to Kcat into divided by Km into enzyme concentration into substrate concentration. The ratio of Kcat and Km is called as specificity constant and it measures the enzyme's catalytic efficiency. Okay. Ratio of Kcat by Km is usually used to measure the enzyme effectiveness. By comparing Kcat by Km of same enzyme with different substrate or of two enzymes with their different substrate, you can usually measure the enzyme effectiveness. Thank you very much for patience listening.